Hello, so here's the second video for chapter 1. We're going to also be looking at linear equations and examples. So now we're going to be looking at demand and supply functions. So again, we're going through the notes, kind of explaining them, but if you need the full video, watch the full video in the lecture. So demand expresses demand, Q, quantity, as a function of price. So price determines quantity, which should make some sense. So M is usually negative. That's the slope, because the idea is that if you increase the price, you'll decrease the demand. That's why it says usually. The y-intercept is the idea that if everything was given away, if price was 0, how much you'd expect. So for example, if you had a demand equation of negative 4p plus 90, where p is the price of a t-shirt, your negative 4 over 1, output quantity, output quantity over input price would be negative 4 over 1. So if you increase the price $1, your quantity would drop by 4 t-shirts. And then your y-intercept 90 means if it was free, price was 0, 90 shirts would be demanded. Now your supply is similar idea, input price, output quantity, but it's how much you can get supplied. And the idea here generally is that the more money you pay, the more you'll get supplied. So an equilibrium was where demand and supply are equal to each other. And our example is, you run a small supermarket and must determine how much to charge for hot and spicy brand baked beans. The following chart shows weekly sale figures for hot and spicy at 2 different prices. So the price is 50 cents, demand is 400. But if the price was 75 cents, demand would be 350. Notice we increase the price, quantity goes down. But for supply, if the price was 50 cents, you'd be supplied 300 cans. But if it was 75 cents, you'd be supplied 500 cans. Notice the supply went up because you're willing to pay more. Similar to the last problem, in the previous section, if you're given 2 points, input price, output quantity, given 2 points, you can find the equation of a line. Make sure you know how to do that algebra. So if I was explaining this, this is for demand. Our slope is negative 200 over 1, output quantity over input price. So if you increase the price $1, you lose negative 200 sales per week. And the y-intercept is when price is 0. So if it was free, 0 price, 500 cans would be demanded. Now, how can I use that demand equation? Well, if I know what the demand is for hot and spicy baked beans, if somebody says, well, we have 410 cans to get rid of, there's my quantity. I could do the algebra to solve that. What price would I need to get rid of those 410 cans based on the demand? It'd be 45 cents. That's when things go on sale and you need to move items. That's the sale price. It can be calculated. Same thing for supply. You're given 2 points from the table and you can figure out supply. Again, you need to know that algebra. So if we're trying to find the demand and supply where they're equilibrium point, we can do like we did in the previous problem where we graph them. But again, we need to know where that point is, and we need to know our window. At what price are we talking? How many cans are we talking about? So again, you can do this all by hand. If you set the demand equal to supply, you would get 60 cents, and then you plug in 60 cents into demand or supply, and you'd get the quantity of 380. I'm going to show you how to do this in the calculator, but remember, if you set them equal to each other, you could solve to figure out the window. If not, you kind of have to guess based on the factors of the problem. So in this case, I go to y equals, turn it on, go to y equals. Remember, our demand is negative. Make sure you use the negative button, which is located here. Negative 200x plus 500, enter. Our supply is 800x, subtraction 100, so be careful when you use negatives, when you use subtraction. Now, if I hit graph, I'm not going to see the lines. You have to understand the problem. So in this case, our input is price. So a can of beans we'd expect to be 0 to $1, maybe $1.50, maybe count by 25 cents. As far as how many cans, we literally have to guess unless you plug in values into either one to get an estimate. We already know doing it by hand, it's be about 380, I think is what we saw. Yep, 380. So we'll go from 0 to, let's say 500 cans. well, I remember the one of the intercepts was 500, so let's go 800 cans, counting by 100. So again, you have to play around with that window a little bit in order to see the supply and the demand. There's where they intersect. If you don't see that, you're going to have to adjust the window and understand the problem and plug in values. So to see where they intersect, second trace, number 5 for intersect, enter, enter, enter. For the equilibrium price, 60 cents for a total of 380 cans. Now again, what happens if you charge more? Well, if you charge more, then you sell less cans. So what happens is, when we talk about supply and demand in our graph, equilibrium is great. It's where they're equal. But if I charge more than 60 cents, we have more supply than the demand. The cans sit on the shelves. If we sell it for less than 60 cents, our demand is higher than supply. That means they're flying off the shelves and we don't have any. So you have to pick the right price to match supply and demand. That's why the equilibrium price is very important. If you mess that up, you don't have any cans to sell. If you mess it up, you have too many cans sitting on the shelves. You need to move them. So you've got to pick the best price. Okay, so it's another example. Now, another thing we can do with the graphing calculator is we can graph, look at data, and find the linear equation. So here's an example where we have some data driving down the Ohio Turnpike. Here's the time in hours. Here's the markers. We collect the data. We pick 2 points. We can graph them and find that line. But the question is, how can I do that all in the calculator? So we have an example here in 1.5 where we're going to look at some data, and we're going to do that. So in section 1.5, it's linear regression, taking data to find that linear equation. And you can read through all this. I'm going to go to the example. So here we have number of powerboats registered and number of manatees killed. And again, the list continues to this side and to this side. So in 1977, 447,000 powerboats were registered, 13 manatees were killed. And in 1990, 719,000 powerboats were registered, 47 manatees were killed. Now I'm going to put this data in the calculator. I'm going to show you the beginning, but I'm not going to type it all in front of you. So I'll take out my calculator. Now first of all, I want to start with a clean calculator. So I go to y equals, clear that y1, clear that y2. To put data in the calculator, we hit stat, then we hit number 1 for edit. And notice there's nothing in list 1. If I had something in list 1, for example 5 and 6, I can go to the data, hit delete. Or if I had a bunch of numbers and I didn't want to delete, you can go all the way to the top, list 1, hit clear, enter, and the data's clear. So make sure your data's clear. And we're going to put the data in, so I'll do the first one for you, 447, enter, and then 13 on the other side. Make sure they match up. And I'm going to go ahead and continue putting all the data in, but we're going to put all the power registrations in list 1, all of the manatees killed in list 2. Okay, so I put all the data in the list, and you have step-by-step instructions on how to do all that. And the question is, how do I find the line that goes through that data? Well, to do that, we're going to do linear regression in the calculator. So I press stat to the right for calculate, and then you notice we have number 4 linear regression and number 8 linear regression. They're both good. The only difference is if you use number 4, the slope is a, which is in front of the x, plus b, or if you use number 8, the slope is b in front of the x plus a. Again, slope is the number in front of x when it's written y equals. So a in this case if you use number 4, b in this case if you use number 8, they are the same. I'm going to use number 4. Then depending on your calculator, if your calculator looks like mine, I'm going to hit second 1 for the x is list 1, the comma above the 7, second 2 for list 2, and then press enter. If you have the newer calculator, it's going to ask you which list, list 1, enter, which second list, y2, enter, and you'll get the same answer. Now notice you get y equals ax plus b, and then you get a and b, but you don't have the r and the r squared, or if you look at the notes, I have those as well. If you want to get that, not really needed for this class, but it's a one-time only thing. We hit second 0, down, 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 down. We're looking for diagnostic on, so you can hold down the down arrow till you get to diagnostic on. Put the arrow on diagnostic on, hit enter, enter again, and then when we repeat that step, stat, calculate, number 4, linear regression, list 1, comma, list 2. Now remember, if you have the newer version, you don't need the comma, just X is list 1, Y is list 2. Push enter, then you get your Y, equals A 0.125, let's say, minus 41.43, and then R squared is a coefficient of determination, percent of data explained by the line, and then R is correlation. We're not really going to go too much into that, but if your correlation is close to 1 or negative 1, it's a very strong relationship, it appears to be. And then R squared is the percent of data explained by the line. So again, we've been spending a lot of time on what does slope mean, what does y-intercept mean in the problem. So you notice it's written here, it's just reverse, so the slope is in the back and the y-intercept is the front, but it's exactly the same. This is what it looks like if you use number 8. So the question is, what does that line mean and what does it all look like? Well, first of all, if I want to graph that line, I go to y equals, I put 0.125 x subtraction 41.43. Now, I can hit graph, and I may or may not see that line because it has to go back to the data. And that's why it's important that we understand what the data is and the line that goes through it. So we have to make sure we have an appropriate window. So one way is to hit zoom 9. That does work, but I highly encourage that you look at the data and make your own window. So if we go back and look at the data, it seems like the lowest number is 447 and the highest is 719. So maybe going from 400 to 800, counting by 50s. The lowest is 13 in the Y, going up to about 50, so maybe 0 to 60, counting by 10s. So I encourage you to push window. We're going to go from 400 to 800 as far as number of powerboats registered, counting by hundreds, looking at the data. Our Y will go from 0 to 60, counting by tens. That would be number of manatees killed. So if I hit graph, I see the line in an appropriate window. And you won't get the window unless you understand the problem. There's no way around it. If you hit zoom 9, yes, that works, but then you're not really getting the understanding part. Now, if I want to see the dots as well, the data and the line, then I would hit second stat. All the directions are here. Second y equals, second y equals, second y equals, second y equals. Go into number 1. We're going to go to plot 1, turn it on, choose scatter plot, the first option. Make sure X is list 1 by hitting second 1 for list 1. Enter. Y is list 2, second 2. And then we have our plot on to show our data. We have our line in there. So when I hit graph in an appropriate window, you'll see the dots and the line that goes through it. What linear regression does is it takes all those points and figures out the best place to put a line. So we can talk about the more powerboats you register, the more manatees are being killed, and we can talk about what that line means and what the y-intercept and the slope mean. So again, all the directions are here. This uses zoom 9, but make sure you know how to do it as well. Don't have to worry too much about correlation. There's your data. Talked about how we got that diagnostic on, how we did that linear regression is all here. But what I'd like to emphasize is what these numbers mean in this video. So remember, the y-intercept is when X is 0. So if we had no powerboats registered, negative 41 manatees would be killed. Well, that doesn't make any sense. They're not going to come back alive. It's what the negative means. But the idea is that no manatees would be killed, and actually it takes some to actually make an impact. Now the y-intercept is, remember, output over input. So output is number of manatees killed over input number of powerboats registered. So this would be 0.125 over 1. So basically, every 1,000 powerboats, 0.125 manatees are killed. Doesn't make too much sense. But if I move the decimal over, let's say 2, and then I move the decimal, well, maybe let's say 1, and you get 1.25, and then move the 1 to make it a 10, I can say every 10,000 powerboats that are registered, 1.25 manatees are killed. Okay? Make sure you practice the calculator, know your algebra, and that concludes Chapter 1.